Hello and welcome to Run Applications Anywhere You Need Them with cloud-like simplicity and performance. Today's webinar is sponsored by Scale Computing and produced by Actual Tech Media. My name is Scott Becker. I'm from Actual Tech Media and I'm excited to be your moderator for this special event. Before we get to today's great content, we do have a few housekeeping items that will help you get the most out of this session. First, we want this to be an informative event for you, so we encourage any questions in the questions box in our webinar control panel. Not only will we have team members responding to questions during the live event, but we'll also have a dedicated Q&A session at the end of the presentation where we'll discuss in greater detail some of the top questions that you ask. That Q&A panel is also the place to let us know if you have any technical issues. A browser refresh will fix most audio, video, and slide advancement issues, but if that doesn't work, just let us know there in the Q&A and we'll provide further technical assistance. Second, in the handout section of your webinar control panel, you'll find that we're offering several resources. There are 3 different PDFs in there from Scale Computing. One on the Scale Computing platform difference, a nice paper on edge computing and hyperconverged infrastructure, and then also another one about hypercore and scribe. So check those out. You'll also find in there a link to the Gorilla Guide Book Club, which is Actual Tech Media's great printed resources on technology topics, as well as a link to the ATM Event Center, which has our calendar of upcoming events. So I encourage you to access all those resources now and share them with your friends and your colleagues. Third, at the end of this webinar event, we will be awarding a $300 Amazon gift card to one lucky registrant. Of course, you must be in attendance during this live event to qualify for the prize. The official terms and conditions of today's prize drawing can be found in the handout section. Just scroll to the bottom and you'll find the prize terms and conditions link there. And finally, one of the best benefits of this event is the opportunity to ask a question of our expert presenter. So to help encourage your questions, we have a special additional prize for you. That's another Amazon gift card. This one for $50 for the best question. At the end of the event, we'll look at all the questions, pick out the very best one, and contact that prize winner. And with that, let's get to today's fantastic content. It is my pleasure to introduce you to our presenter today, Craig Tiriac, Vice President of Product Management at Scale Computing. Craig, welcome to the webinar.
Thanks, Scott. Appreciate you having me on. I'm excited today to join you on this.
Well, thanks for joining. Yeah, so take it away.
Okay, great. Yeah, so I'm here today to really talk about a couple things. Really introducing Scale Computing Platform, SC Platform, as you see on screen here, is alongside Scale Computing Fleet Manager, which is a new tool that we have now in our tool belt, specifically around edge computing. So most of today's content is really around edge computing and kind of bringing cloud-like simplicity and performance to that type of environment. So those of you who are familiar with Scale Computing, this is probably a refresher, but just for those of you who have not heard of us before, we are headquartered in Indianapolis, Indiana. I'm actually based out of our San Francisco office, which is where a lot of our development team sits. I'm in the product management team working alongside that product development team. We originally launched our first product back in 2012. So we're actually coming up on our 10-year anniversary here. And since launch, we've really amassed thousands of customers across verticals like retail and state and local government, education, manufacturing, healthcare. I mean, you name it. It's really anywhere that you have critical applications that need to be run with high uptime and managed with minimal resources. Those are kind of the 2 key things of where you would see Scale Computing fit in with our HCI solution and why we're successful there. This originally, if you had heard of us back in the day, it's probably around the SMB space, which is where we really focused when we first launched. But it's really grown from there through MSPs, and then the last 5 years or so, even into this large distributed enterprise environment, looking at edge computing as a platform for that type of workload. And so, again, just kind of going back to the focus, it's on simplicity and ease of use. And I think you'll see it on our Net Promoter Score there. It has served us well, focusing on that type of deployment where ease of use and kind of high availability are king. So I've used the term edge, 4 times now. Some of you out there are probably saying, what is edge computing? So let's start with that. Really, edge computing is anywhere that mission critical workloads are being run outside the 4 walls of the data center or the cloud. And the edge is The edge specifically is just that physical location. It is the place where people and things are connecting into the network and generating and processing data. And so edge computing then is the platform, it's the infrastructure and compute running those applications out at the edge of the network. One of the questions I commonly ask, and I'm on a lot of customer calls, typically outside of the sales process being in product management, but I get to ask questions like, well, why wouldn't you just run this in the cloud? Why are you talking to us, a company that sells on-premises HCI offerings? And commonly, I will hear them respond in one of these 5 ways. They'll say, I can't run in the cloud because it's too expensive for my workload. So, whatever cost savings management thought would happen, and a lot of times it's that cloud first initiative really is a top down, starting at the C-level, and they come and say, hey, move everything to the cloud. And the real design behind that is that you'd be able to get rid of IT infrastructure resources that would need to be managing that infrastructure. And if that is still needed, then you don't necessarily have the cost benefit of moving to the cloud because of that. The second thing I hear is just the volume of data, gathering so much data that's too large to send to the public cloud. And it's not like there aren't solutions to that. You could increase your pipe, which again comes back to cost as probably being a prohibitor there. And it's pretty common with things like video workloads where you're capturing a lot of data, where there may have even be kind of a natural decay to the value of that data, where capturing it on premises, processing it on premises makes sense to do it and not send it up to public cloud for any long-term storage, archival, or anything like that. Latency is typically the third thing that I will hear. It's, I've got an application that needs to be run on premises, whether it's the people or the things connecting into that application. They can't wait on the latency of the cloud to actually process that data. And so a lot of edge computing examples that you read about really fall into that category. It's things like self-driving cars, or commonly just computer vision, where real-time decisions are being made using AI, machine learning, that type of workload. So latency is a very common driver, and there's several different possible ways to solve for that solution, but primarily bringing the infrastructure as close to those things and people is how you cut down on that latency. The fourth thing is, I would say honestly, of all of these, the fourth thing, resiliency, is what I hear most commonly today. It's somebody that has a large distributed enterprise where they've got a location that just doesn't have a great internet connection. It's a retail environment where maybe a lot of the retail stores are in locations that have a great connectivity, but some of them are in small malls that have terrible coverage, and you just cannot rely on the internet connectivity to be there to run things like point of sale system or other workloads that require uptime without having an impact at the bottom line. Actually, I spoke to a really interesting customer last week in the maritime space. They've got ships going in and out of the international waters and really only have cell coverage, which works intermittently, but with fairly poor bandwidth. The surprising part to me was that the place where they actually had the least coverage was in port. It actually wasn't out at the open seas. It was in port because they're a container ship, and these massive cranes that are going above the container ship pulling containers off just act as a giant Faraday box. They can't even get data in and out. So some need for autonomy, some need for having infrastructure on premises in those environments where you can run your workloads and not rely on the internet connectivity becomes pretty critical. And then the final one that I hear is regulation. It's things like personally identifiable information that needs to stay on premises. Regulations like GDPR, HIPAA compliance, either industries or regions where regulation may require data to stay on premises. That comes up pretty common. A few months back, I actually spoke with a fairly large retailer in the home improvement sector that told me that they were actually regulated by FEMA, of all things. They're considered critical infrastructure, and so they were required through FEMA to stay open federally during declared disasters. So it's kind of an interesting regulation use case. Now, I know we have a poll coming up here, so let me pull that up. I'm kind of curious from the audience what reasons you have for running infrastructure on premises and not in the cloud.
Yeah, Craig, you really set this poll up very well with that last slide going through those. And while we give everybody an opportunity to answer that there, which is, what is driving the need for on-premises computing in your environment. And, so it's like cost, volume of data, latency, resiliency, and regulatory stuff, all the things that you were just talking about in the previous slide. And just while we're waiting for people to come in, I thought that story about the ship in port not having connectivity there, it being like, the cranes being like a Faraday cage. That's fascinating. Just the opposite of what you would expect. Yeah.
Yeah, just the opposite. I would say one of the most common things I hear from this is even that retail that I was referencing, where I said, why are you doing this? It's usually two or three. There may be one that's driving it. For them, it was regulation, and it was only in certain areas. For others, it was, they had those remote sites that didn't have internet connectivity. They also just in general thought cloud resources were too expensive for the low margin business that they were in. And so those things often combine. So it's not surprising as the results come in up here that it's spread pretty evenly across them. Even some of you, which is great. If you can run cloud computing, do it. It's great. There are a lot of benefits to it, right? It's for a long time now really accelerated our ability to support this digital business transformation that we're seeing across the industry. And it provides great availability. It provides great scalability without the burden of managing the IT infrastructure. And so if you can do that, you absolutely should. What we're seeing though
Yep.
is that in those workloads where you can't, there are problems. And so that's kind of where I was going to lead next here, is just into some of the issues that we see with these types of deployments. So once you've decided, I have to run on premises, now the next question is what solution are you going to look at? And so we'll commonly see people look at things like a point solution, right? So this is one of those where just over time, somebody within the organization says, hey, I want to deploy application X, whatever that is, some new whiz bang great thing that's going to add a lot to the top line of the business, or lower the costs of operating something like that. And they'll go to the application vendor and say, okay, what are your hardware requirements? And they'll just buy whatever box is being recommended by that application vendor. And it's easy because it's on paper. We know that vendor's going to support it. It's kind of it goes along with the purchase of the application. So it's, if you're going to go through procurement, a lot of times it can be done all at once. But the problem with that obviously comes down to the management of it. You've got several disparate boxes out there that sit out across maybe one site, maybe multiple sites. It can be really a bear to manage all of that. And one of the things that I think people often forget about is it's not just the manageability of it; it can be the security as well. It's things like every single one of those boxes out there may have critical information on it that may be sitting right next to the cashier, maybe sitting next to the machines physically accessible to anybody within the organization and sometimes external to the organization. And so there's this attack surface that just grows exponentially with every single one of these point solutions that you put in place. And so minimizing that is really a best practice. And so moving into that virtualization infrastructure in the center there, that's usually the next step that we'll see people do. It's like, okay, well, I can at least consolidate some of my applications onto a host or two. The challenge with this, though, in this type of setup, is that without shared storage across them, you don't really have the benefit of high availability. And so you're kind of adding virtualization, which is a step in the right direction, but at a cost of a pretty delicate infrastructure that probably adds the overall management cost, not compared to the point solution, but compared to some of the other solutions we see out there in the market. And then the last one is this 2-2-1 infrastructure. Oftentimes this is referred to as 3-2-1, where you've got 3 individual host servers connected into redundant switching into a SAN or a NAS. We're calling it 2-2-1 here because usually these are going to environments that are only running a handful of applications. Maybe 3, 4, 5, 6 applications in today's legacy VM world running on these types of environments. And so 2 hosts is usually sufficient for those environments. Introducing the SAN, obviously there are benefits to doing that. You have the high availability that's baked in. If one of those hosts fails, the applications that are running on that host are just going to restart on the other host in the system, and life is great. The problem is that, you can kind of see just from this architecture of the slide here, there's a lot of complexity in it, making sure that you've got, the SAN administered correctly, making sure you've got the switching administered correctly, making sure that the hosts are set up correctly, and not to mention the applications themselves running on top of that. And so the overhead of adding in that SAN or NAS, while it does provide the high availability that people are seeking in this to keep high uptime for their applications, oftentimes it's the least desirable of all 3 of these that we see people actually choosing out there, just because the overhead of having to manage that separate storage infrastructure. So that is that's kind of how people are solving it today. The challenges, though, of edge computing are broader than just those solutions that I put on premises. Excuse me, put on that last slide. It really comes down to the fact that these challenges are being of deploying out at the edge of the network are different than what you would see in the tier one environment. For one, there's limited to no IT staff on premises. There's usually no one on site that has the technical expertise to deal with the infrastructure. So have you tried turning it off and on again? It works sometimes. It's not going to work every time, and it probably doesn't cut it for most deployments, especially if you're looking at several hundreds of sites. So you either need a solution that provides a high level of resiliency with the appropriate tools for remote management, or you need to supplement with a fairly expensive 4-hour on-site replacement program through a managed service provider that has parts depot ready to go in whatever remote parts of the world that you might have these locations. It is a challenge to deal with anything out at the edge of the network when you don't have physical access to it. And because of that, you need different solutions than you possibly could put into a tier one data center. Similarly, physical constraints. These are, again, the edge of the network is not a tier one data center. It's messy. It's, dust is a thing that you probably have to worry about. If you're in a manufacturing environment, that's something you're going to have to take into account. Temperature is another thing. So, power and cooling and all these things have to be factored into the equation alongside the form factor. One of the grocery retailers that I'll reference later in this deck here is one called Ahold Delhaize, and they commonly joke that their infrastructure sits between the bananas and the pineapples, and obviously it doesn't actually sit between the bananas and the pineapples, but their point is this is going into a retail environment and likely accessible to a lot of people. They actually have to take that security mindset in deploying these and make sure that it is physically secure somewhere that somebody cannot access these things. And so, whether it's under the desk or in a back office or maybe a small telco rack, it is not a tier one data center, and that needs to be taken into account. Connectivity and outages kind of goes along with the resiliency that we talked about earlier. It's if you're deploying at a remote site, or potentially, let's say you go investable in the example that I gave earlier, in kind of that extreme use case, you will need to protect against the reliance on connectivity to the internet. And then the final one that's kind of the unsung challenge that nobody ever really talks about. It's just the unpredictable demands of what is going to be asked of that infrastructure in the future. It's one thing to size for what you're going to be running today. It's another thing to size and put into a solution that is able to kind of future-proof you from whatever cool thing is coming down the pipe. I mean, the expansion of IoT, computer vision, AI, machine learning, all sorts of these nascent technologies that we can use in really clever ways that are unpredictable, not only to the businesses that are trying to come up with solutions around them, but also to the companies that are trying to deploy these, and more likely the teams that are responsible for the infrastructure where those applications are going to sit. And so, needless to say, this is this kind of sets us up for what you really need is a solution that cares for itself. You need something that provides the availability to minimize downtime in the event of a failure with minimal management overhead. A solution that's simple to set up and maintain over time, something that provides efficiency in the environment that allows you to run on maybe smaller form factors than you have traditionally in those types of environments, but still offers that really robust enterprise level performance for the applications that you need to run. And then finally, the flexibility. Again, the concept being you need something that is future proof that can run both those legacy applications that you might be running today alongside some of the future cloud native applications that you may not even have visibility into today. So I thought what might be fun today is to kind of talk through the scale computing platform solution and give a deep dive demonstration of all the different components and kind of how they fit together into an overall solution for these types of edge deployments. Real quick, though, on the screen here, you'll see two different pieces of the scale computing platform. On the left-hand side, you see SC Fleet Manager. On the right-hand side, SC Hypercore. So Hypercore, if you're familiar with scale computing and our HCI appliance, Hypercore is it's a software that runs on premises. It's the HCI stack. It's a easy to deploy, fully integrated virtualization solution that's providing that high availability. Fleet Manager is the monitoring solution that's a kind of a cloud-based centralized management for deployments from 1 to 50,000 clusters, and it's what ties all of these independent hypercore clusters together in a really easy-to-use interface and management platform that's cloud-based. And so combining those two things together alongside the hardware that might be running HyperCore is what we call scale computing platform. So let me share my screen here. Actually, real quick before I do, again, kind of going through those concepts again. Scale computing platform, the overall solution. You'll see me pull up Fleet Manager first, which is where I'll log in. And then I'm actually going to walk through demonstrating one single cluster here. I've got actually took a picture of my cluster that is sitting on a shelf in the other room. You'll probably hear me fumble around as I walk over to that because we're going to demonstrate what high availability looks like in this type of environment. So HyperCore is running on these nodes here. Those of you that are very familiar with hardware may recognize these as Intel NUC based. And whether it's this really small form factor that I'm showing on screen here, or some of the 1U or 2U rack mount servers, the solution and kind of how you interact with the interface and the APIs and that sort of thing, those are all unified across whatever hardware platform you choose. So it's fairly hardware agnostic from that perspective. So with that, let me pull up my screen. And Sky, I'll have you verify once this comes up that you're able to see that all right.
I see it.
Perfect. And not much of a delay either, so that's great. So here I'm pointing to fleet.scalecomputing.com. This is, again, is Fleet Manager. This is the cloud-based user interface for managing a fleet of HyperCore clusters. And I can type in my email here, or you can't actually see me on screen here, but I've got an issue going on with my hands. So I'm just going to log in with Google, which is going to make it a lot easier for me to log in here. And once I've logged in, you'll see what my fleet looks like. And of course, I'm connected to a whole lot of clusters sitting in our lab that are in varying states of disarray, mainly for the pretty pictures that it provides here, but also so I can kind of give some examples of what real world failures might look like in an environment like this. And so I've got 19 individual clusters out here, all connected in some fashion. You can kind of see the condition timeline over the last 24 hours or so that tells you what has been going on in the cluster. And sometimes it's also really important to understand what firmware version you're even running on these, which I'll kind of walk through what upgrades look like in this type of environment. So if you recall on that last slide that I showed, that 3-node system that we were looking at that's sitting on my shelf just neighboring me here is this HE150 promo cluster here. It's sitting here healthy right now. It's a 3-node solution. It's running a handful of VMs. I thought it might be fun to just kind of walk through what it would look like to first deploy this and just kind of talk through all the steps you would need to go through to get a small form factor cluster deployed like this. Usually when I'm giving a demonstration like this, there are a handful of things that I really try to hit on hard. The first one is ease of use. It's, you don't have to go out and get certified on our platform specifically. It's, if you can administer Windows, you are more than capable of administering an environment like HyperCore and Fleet Manager combined into this platform experience. So the very first time you deploy these, again, small form factor, each of these represents a node that I have sitting on my on the shelf next to me here. And you'll see that the very first time you unbox these things, you're going to plug in the power, you're going to plug in networking, you'll assign an IP address to each of the nodes in the cluster, and then you'll initialize the cluster. And that process is all it needs to reach out and connect into Fleet Manager so that you can start managing this through your Fleet Manager interface. Obviously, if you're deploying several of these, everything I just talked about doing manually, well, even though it takes an hour or less, if you're doing this across 100 sites, you don't necessarily want to do that every single time. So we've got advanced tools there that would allow you to even do zero-touch provisioning using a USB to plug them back in the nodes and have them auto-provision themselves based on whatever information you've already put into there. And there are a lot of other tool sets around the product like that are really designed to extend the ease of use that we have here in the user interface to just the overall system deployment and kind of other things you would need to be able to do with the life cycle of workloads on this type of environment. So here I've got my 3-node system. I'm actually running 4 individual VMs on here, but if this were the very first time you were spinning this up, you wouldn't actually have any VMs on here. And so let me walk through creating a new virtual machine. So here I'll give it a name, give it a description. I can set tags on this. We'll commonly see Windows and Linux variants running on HyperCore. And the last thing you have to do is just carve up whatever resources you need for this particular workload. Here I'll select an ISO that I've actually dragged and dropped onto the user interface, so I have access to that, and I've created a VM. And again, this demo VM that I've just created, you know, I'm going to start this up. It's automatically highly available. I haven't had to do anything complex at all. All I'm doing is saying, what resources does this need? And again, it's probably worth calling out that even though I just did this in the user interface, you don't necessarily have to do this by logging in individually every single time. In fact, in the 9.1 release that I'm running here, we've actually introduced some extensions to our REST API that allow you to use CloudInit. Those of you familiar with CloudInit probably recognize the benefits that would bring, but essentially it allows you to take kind of a vanilla Ubuntu operating system or some kind of Linux operating system, spin it up and automatically apply things like user data, metadata, assigning IP addresses, assigning users and groups, and kind of all the things you would manually have to do to provision within a VM. Not only can you create the VM using the REST API, you can even go through all the way through deployment of the applications on top of the VM in a very scripted manner, to where rollout becomes just a breeze for these types of deployments. And so that's also what we see people using that are familiar and deploying containers and Kubernetes and those types of workloads, is that they will use this at the very end of their CI/CD pipeline, kind of hand off those endpoints to their DevOps teams and say, here's your infrastructure. Rest assured, anything you create on here is going to be highly available, and kind of let them go to town. You'll see I just created a virtual machine on here and started it. When I started it, the very first thing it does is actually, it's probably worth calling out. We have what we call state machine technology. So the state machines are monitoring thousands of conditions on every host and every node that we have in the system. And those conditions are looking at things like, do I have sufficient memory to start all VMs on alternate nodes? You can see that I've got all sorts of warning lights going off here because I've actually started a VM on this 3-node system that's preventing me from being able to fail over the VM. So the VMs right now are not highly available because I've actually over provisioned here. And so to alleviate that, you can do one of two things. I can either turn off this VM if it's not necessary, which for this demo environment clearly is not, or I can just add another node. And adding a node in this type of environment is exactly the same process that I just talked through with spinning it up. You can mix and match node types, from CPU to the storage resources to you name it. Just add another node into the system. It's going to aggregate the storage in such a way that it's no downtime to the running virtual machines that are running on at the time. And in fact, for those that are more I/O bound, it's even going to increase the performance of those workloads. So here I've got my VM that I've just started up. The state machines are monitoring to make sure that I can tolerate a failure. As you saw me select Windows 2019, here's my Windows screen, just so you can kind of see what that looks like within the console here. I'm actually going to shut this down so that I can tolerate a failure, because I think, even though we've hit on the simplicity, I think the next thing to really show off here is the high availability. So going back to our examples of really remote sites, or any site that does not have a lot of IT expertise on premises to deal with hardware failures, you have to have a solution that is able to tolerate failures in hard drives. In my case, I'm running NVMe here, less likely to fail than a spinning disk, I would say, but it can still fail. And if there is a failure, you have to be able to tolerate that. And so the system that I was just talking about, that is monitoring to make sure that we have enough available resources to restart VMs in the event of a failure, that's the same kind of state machine technology that we're using to validate that there is a failure. So let me run into the other room here, and you'll hear me fumble around as I go to unplug this node. Again, this is a small form factor based on the Intel NUC. This it's probably, actually, those of you who saw in the picture, it's about the size of a cell phone. So really, really small form factor. And these happen to be running at about 16 gig of RAM and a 500 gig NVMe SSD, varying capacities and things. And again, the interaction of the node itself wouldn't matter what resources you're running on, you're still going to experience kind of the same type of thing. So what I did is I actually pulled out, I wish you could see me right now, but I pulled out one of these nodes from the cluster. It's actually still warm in my hand from running the workloads here. It's this third node here. So I've got Minikube and a file server running on this particular VM. Because I have shared storage across these 3 nodes, it's able to tolerate a node failure here. So whatever data sits on this node also has a replication factor of 2. So there's a separate copy of that data somewhere else in the cluster, which is what allows me to do things like rolling upgrades. It allows me to do things like live migration, allows me to do things like tolerate a node failure. So the state machines that I was talking about earlier have detected here, hey, I don't actually have access to both copies of the data right now. So data redundancy is degraded. Right now, the state machine is validating that this isn't just some kind of transient issue, that this node is indeed offline. And since I'm physically holding it, I can assure you it is offline. It's not connected to power or Ethernet. And so once this validates that, yes, this is a failure, it will automatically restart whatever workloads are running on this node. It will restart them somewhere else in the cluster. So again, going back to this concept of the deployment nature of an edge computing deployment out of distributed enterprise or even in a small business, it doesn't really matter. The concept being, if there's a failure, as the administrator, you don't have to rush out to fix it. You can rest assured that you're going to receive alerts through syslog. You'll receive alerts through email. You'll receive alerts through Fleet Manager saying, this node is offline. Don't worry, the virtual machines that were running on the node have automatically restarted. It's not uncommon that customers will call us and say, hey, I've had a node down for the last week and I'd like to have it replaced at some point. And the reason they're able to do that is because everybody connecting into these VMs, everyone, all the things and people out at the edge of the network that are interacting with the applications that are running on these virtual machines here may or may not even notice the downtime that it took for that node to be detected as offline and restarted elsewhere. Again, though, monitoring this is no longer about what an individual cluster can do. It really comes down to, what does this look like at scale across my entire fleet of clusters? And alongside that HE150 that is in kind of a state of disarray of having a node removed from it, now I have a whole bunch of other clusters in my environment that may also have issues that I might need to dig into. Everything from looks like I may have dropped my network here. Scott, are you still able to hear me okay?
Yep, I can hear you.
All right, perfect. So that's kind of the concept, is that you have a I'll stop sharing just so that we can assure my bandwidth is still up to snuff here. But the concept is, individual clusters themselves are fairly autonomous. They can go in environments that you don't need IT resources on premises because they just work. You set them up, they're going to run the applications. Failures are expected, they're tolerated, they're in some cases even predicted. And the notifications, the ability to manage and monitor this at a fleet level now exists with Fleet Manager. One of the other things I didn't really talk through in that demonstration there was the fact that you can do things like upgrade the cluster now centrally from Fleet Manager. So if you have a new upgrade, so I mentioned 9.1.14 just became a GA release in the last couple of weeks here. When that hit the update server and people had it available to apply, through Fleet Manager, those users could go in and click a single button. And what that does is it goes to the very first node on whatever cluster that's connected to and migrates the virtual machines off. So no downtime for those applications, those VMs. It updates everything from the BIOS and the firmware, the hypervisor, the storage stack, the operating system, kind of the entire thing, from top to bottom. Might even restart the node depending on what type of upgrade it is. Once the node is back online and nominal and running whatever the latest version is, it'll migrate the virtual machines back and then just rinse and repeat through every node in the system. So no longer do you have to manage all these disparate things. The storage stack separate from the hypervisor, separate from the applications. You can kind of keep it as a full unit that is tested together as a kind of a working solution, so that you can upgrade these things. And a lot of people, they start a little timid just because they are so used to Microsoft updates that may cause issues. And over time, you'll start to see them deploying these upgrades just in the middle of the workday. Not a big deal. Just, hit the button, walk away, come back, everything's been applied. So very, very powerful tool set now alongside HyperCore that really provides a complete and comprehensive solution for edge computing. And that again, kind of overall solution is what we're calling scale computing platform. I'll end on this, which is just what customers are saying. So this has been in the works for a long time now at Scale Computing. We've amassed a number of customers that are using Fleet Manager today as part of their overall solution, and the feedback has been really phenomenal. And most of it is pointing to the time savings. It's there was already time savings from HyperCore itself running on clusters out at the edge of the network, and we're now seeing that IT managers with multiple clusters are seeing load maintenance time being reduced by 50% or more beyond just what HyperCore was able to do alone. So Scott, with that, let's open it up to questions.
Okay, great. Yeah, and there are a lot of questions coming in, so this is great.
Perfect.
And Craig, love the demo. Always love to see somebody yanking a node out of a cluster. That always makes for a fun demo. So appreciate that. Um, First question for you: is there a REST API or Ansible plugin for HyperCore clusters?
Yeah, that's a great question. So, a lot of DevOps teams out there clamoring for those types of tools, and yes, we do have an Ansible plugin that we can give people access to, as well as a very well documented REST API with examples out on GitHub that people can reference, and a whole community of people you can ask about how to use these things. As I mentioned in 9.1, we did introduce Cloud Init, which is again kind of a pretty powerful extension to that REST API. So you can even go and define things beyond just the VM lifecycle into the workloads themselves. So you've got a container based application or a Kubernetes based application, and kind of want to have that at the very end of your CI/CD pipeline. You can kind of monitor and manage that entire process using the REST API with Cloud Init.
Okay, super. Hey, that leads into a question that came in from Florin. I guess, based on the demo, is asking about, VMs. Does this solution support other types of resources? I assume that's a yes, since you were just talking about containers as well.
Yeah, that's right. It's it's funny. We've actually had this change internally, I would say, in the last year or two, where when we talk about it used to be VMs. Now it's workloads, because we don't know what people are running, right? It's sometimes
Hmm.
it's VMs, other times it's containers on top of VMs, which is a fairly common way to deploy containers out there. It doesn't matter what your runtime is. It's you want a kind of a small sandbox environment to be able to run that container. And we've actually partnered with a lot of companies, container management platforms where you can put an agent within the VM and have those container management applications manage that container deployment for you, which is pretty cool. We also have a lot of examples out there of people running, I think in my environment, I've got Minikube running, but things like K3S, really smaller versions of Kubernetes that are more intended to be running at the edge. Very, very common to see.
Hmm. Okay. All right, great. Next question here. For someone with multiple sites, do you have tools to help with the provisioning of clusters?
Yeah, so I mentioned this briefly as we were talking about the setup, right? So, the manual steps that I walk through verbally whenever I was talking about how I set up my demonstration environment here is, you plug these things in, you assign an IP address to them, you initialize the cluster, and, usually takes me 20 minutes or less. I would say a first-time customer, probably an hour or less. But if you're doing this in mass, you really need the tool set to be able to back that up. And so we have what's called zero-touch provisioning with a USB, where you can apply an entire configuration onto a USB and pop that in the back of the node. So if you're a large enterprise working with an integrator that you might have this, our nodes going in alongside maybe a UPS and some switches in a small rack, and you've got somebody that is combining all those things together, we can help them with a tool set that says, hey, here's how to minimize the overall amount of time you're going to have to deal with initializing these clusters, which obviously is going to then tie into a lesser bill to the people that are asking those integrators to pull those in. We've got some really interesting things right around the corner on this. So in the next quarter, you'll see some announcements related to zero touch provisioning and kind of extending that USB based version into a more comprehensive solution that I'm excited that in a month from now, Scott will probably talk again and we'll go into a lot more detail about that.
Okay, I'm looking forward to it. Next question here comes from Yogo's asking, can scale computing run on any hardware of our choice?
That is a great question. The answer is yes. I mean, everything that we have today is x86 based. Now, I would say 95% of what we sell is integrated at scale and shipped out fully as an appliance. And that's really to maintain this kind of that out-of-box experience I was talking about, where you don't have to image the nodes. It just works. There's the other 5%, I'll say. We have partnerships with companies like Lenovo, where you can go to lenovo.com and select whatever hardware you want from the OEM on demand section, and that will ship out with our software on it. So same out-of-box experience, where you don't necessarily have to be the one that applies the image itself. And then we have, somewhere also in that 5%, a handful of customers that have come to us and said, hey, I've made a large investment in resources already out at my sites. Can we certify this type of node? And the answer is often yes. There are some caveats to that. We maintain a really, really strict HCL, intentionally so. When I was talking about the upgrades that we maintain, where we're doing everything from the BIOS and firmware on up through the hypervisor, the reason we're able to do that is because of that strict HCL we have, where we're able to say, hey, we're going to take on that hardware management for you so you don't have to, which means we have to have really tight integration with those manufacturers. And so we've got a pretty wide list of OEMs that we work with. I mentioned Lenovo, Dell's another one, Intel. There are a handful of options, including the NUC, which I demonstrated in my environment. And we'll continue to expand upon that. Supermicro is another one I would say. So if you have requirements that fall outside of something we have already certified, we will figure out a solution for you. Most of the time, you'll fall within something we've already certified, though.
Okay. All right. Super. And Adam's got sort of a related question. He's wondering, does this apply just to compute clusters, or are there storage specific, elements that are supported? I wonder if you could talk to that a little bit.
Good question. So, I talked about scalability in the sense of, hey, how do I manage this at scale? And you've got a bunch of different sites, and not every site has to have the same resources, and it's very flexible in that manner. But I didn't really talk about the scalability within a cluster itself. And that really is important, especially when you talk about future proofing for those things that you don't know are coming down the road. We will usually see people deploy clusters of 3 or 4 nodes, somewhere in that range, where most of the nodes will match. We do have flexibility that allows you to say, here's a great example, right? So you've got Microsoft, they get their licensing, right? So if you're going to deploy data center on a cluster, know that Microsoft is going to say, we're going to license every core that this cluster has access to. And so because of that, oftentimes we'll see people say, can I just add another node? I just want to scale out my storage. Can I do that? And the answer is yes. So if you see that your storage is outpacing your compute, you can add another node in what we call storage only mode that basically presents the underlying storage and aggregates that together along with the rest of the storage that you have and the fully compute capable nodes. But it doesn't expose the compute, which allows you to kind of scale out that side of things without affecting your Microsoft licensing in this specific example. But yeah, there's a lot of flexibility in that.
Great. Next question is, will Fleet Manager be available on mobile devices?
I almost demonstrated that today. Yeah, it is actually. In fact, I get made fun of often by our team because one of the first things I do when I wake up is roll over, pull up my mobile phone. I use an iPhone, kind of pull that up and look through to see what has happened overnight. And I think that's a fairly common use case, but I will say my team makes fun of me because I'm the one who's reporting on, hey, I found an issue with the layout of this type of thing. But it is 100% mobile friendly. And I said I almost switched displays in the browser so you could see what that looks like. But yep, great question.
Deepak has a couple of security questions. He's wondering how security is being taken care of. And also wondering if role-based authentication is available. So I wonder if you could talk a little bit about sort of the security of scale computing solution.
Yeah, that's it's probably something we should spend more time of just in our standard deck as we talk about the solution, because security is of utmost importance in these types of environments. As I mentioned, going into the edge, there's not a lot of physical security. You don't have a security guard standing there on duty making sure somebody's not putting some rogue USB into the device, and so security is absolutely important. So we do have role-based access control on the clusters. We have role-based access control within Fleet Manager. We've got single sign-on integration for those types of use cases too, so you can use two-factor authentication with your Azure AD and that sort of thing. So yes, that is being taken care of. We're also looking at things like ISO 27001 and those types of just ISO standards to be able to say that this is being developed in a way that is secure. And so there's a lot of effort going into exactly that.
Okay, super. Hey, we had a couple of questions about just cost in general in HCI solutions. You had mentioned about how people work around say paying for an extra license of Windows Data Center server when all they really need is some more storage. But there's a question here: what are the cost considerations to be aware of in a 2-2-1 scenario like you showed?
Well, the biggest one is the intangible time and effort in setting it up and managing it, I would say. I mean, there are obvious other ones that there's a premium on SAN storage compared to just direct attached, obviously. But even ignoring that, the intangible, I think, is where the biggest cost is. If there's an issue in that environment, how are you going to actually address it? And again, for our on-site support is great if you know exactly what failed, because then they can run out there and replace it. But it's usually diagnosing where that failure sits. And so, you've got a hypervisor vendor that may be pointing to the server vendor, who may be pointing to the storage vendor, who may be pointing to the switch vendor, and switch vendor says it's never the networking. Why would it be us? And you just get a lot of finger pointing. Whereas if you look at an HCI solution, whether it's Scale or somebody else that is fully integrated, where you own the hypervisor, you own the storage, you own every piece of the stack, it's a single phone call, or in a lot of cases, just a chat within the user interface. And you don't necessarily have to, you can skip a lot of the who's at fault here and how do we resolve it. So that is where I would focus my attention.
Okay. Yeah, fantastic advice. There was a couple of like licensing and pricing kind of questions. Like one is Yoga's wondering if there's an OpEx model to pay for what is allocated or used, or is it mostly a CapEx approach? How do you guys go about that?
Yeah, we're seeing more and more demand for OpEx models, mainly to align with the operating expenses out at each of these individual sites. That just seems to be how people view this. Today, we have separated the hardware from the software, and we've got some options there, especially through our managed service offering that allow you to purchase kind of on a monthly basis based on the resources that you're using or you need. On the hardware side, it becomes a little more of a challenge. And I would say it is something we are looking at solving. But right now, I would say the best option there is likely leasing if you're looking for monthly payments. It doesn't necessarily get it into a full OpEx model, which is what we're trying to solve for in the long term. Great question, and one that is top of mind for me in product management.
Okay, so a definite stay tuned situation there. Excellent.
Yep, absolutely.
Okay. We have a question from Nick, who's asking about, scaling across different cloud platforms. And I'm interested in that too, because we're talking mostly about an edge scenario. Like, I'm going to keep coming back to that ship at port, which, I love that anecdote. But, the prime value is, an edge system that's not necessarily connected, but are there options for, pulling in, virtual machine from the cloud? Do you guys connect to that, or is that really sort of outside the scope?
It's outside the scope of Fleet Manager today within our user interface, but we have had customers that will take something like Google Anthos or really any public cloud provider's management stack and manage the workloads running on on HyperCore separately. Cohesively within that interface, as opposed to separately with Fleet Manager. So there are options available to be able to bridge that, and I do expect that is going to. And you can almost treat Edge as yet another cloud in a lot of ways, and so I think the extensibility of our product into those other options is going to be required over time.
Gotcha. Yeah, and there's another question here about just integration with enterprise monitoring and integration services, like ServiceNow or Splunk or New Relic, et cetera. Your interface looks great. for managing it individually, what do you guys connect into? What do your customers typically use to also keep an eye on things?
I would say Splunk and ServiceNow are both really great examples of common apps that we will see. In the MSP space, we'll also see ConnectWise and other tools like that. And yeah, it's we've got, as I mentioned, we've got a full REST API that allows you to really have that broad scope. There's also the ability to connect into, so Fleet Manager as a concept is pulling together all of the individual sites. Obviously, under hood there is an API that basically says, hey, here are all the sites you have access to. And so using that as a proxy in the future, I think, is probably the best way to integrate with some of those types of tooling. But even without that, you do have options available today to integrate, and that's what we see customers do.
Okay. We've just had there's just a flood of questions coming in from the audience, which is fantastic. Really speaks to, how critical what you're talking about is today. But sort of one here from Cal might be a nice one to start to wrap up on. He's asking, what are the 3 takeaways that differentiate your solutions to other providers? So I'm not going to hold you to 3, but take that question however you like. What are some of the key differentiators there that you'd like people to come away with?
All right, for the next 9 minutes, I'm going to go on a rant. You ready? No, no. I would say, there are a lot of solutions in the HCI space. I would love to say that the decision I'm about to talk about was 100% intentional to take on edge computing, but it was 100% serendipitous. So we decided very early on, again, almost 10 years ago now, I think it was in August when we first launched our original HCI product. When we launched with a KVM-based hypervisor. That decision alone is probably the biggest differentiator we have in the market, because we created a storage layer that we call Scribe. It's Scale Computing Reliable Independent Block Engine. It's a block-based storage layer that it's intentionally designed to be consumed by the KVM hypervisor. And so the benefit to that is that it is extremely efficient. And that efficiency allows a couple of things. Number one, it allows really great performance, which everybody loves. But where it applies in this edge computing market is that it allows us to run on really, really interesting form factors that others can't run on. So that example demonstration that I gave earlier, where I had a cluster that was running 16 gig of RAM per node, of that I was using 1 gig of RAM for our operating system and storage layer. And you can kind of go down the list of pretty much any other vendor out there in the HCI space, and it's and probably the most efficient I've seen is somewhere around 12.5 gig per node. The biggest kind of 800-pound gorilla in the HCI space is somewhere closer to 24 to 32 gig per node. And I would say in the most exacerbated cases is somewhere closer to 100 gig per node. And again, just to run the operating system. So ignore the resources that you're paying to run that. It would absolutely preclude those vendors from being able to run on these smaller form factors that are so appropriate in these types of kind of edge computing environments, where it would take a lot of effort and work to remove functionality and architect to be able to operate on an edge ready node like we have. And I would say all of those things combined, that's the special sauce. That is why we're able to be so appropriate in edge computing. And if you combine that, I don't think I did service to the concept of the state machines that I was demonstrating earlier. The entire reason that these things can go, on that ship out at sea and rest assured that everything is going to be working is because it's as if there is an administrator that is sitting in the box making decisions. These state machines, the way they're architected, you basically say, let me know the lay of the land of everything that's going on, and I'm going to monitor all these individual points of data. I'm going to make sure that that data can be relied upon. And then once I've decided it can be relied upon, then and only then am I going to make decisions based on it. And so I know my current state, and I know the desired state that I want to be in. So, the common example that I showed earlier for that node being offline, desired state for every workload that was running on that node is online. And so it's going to work as best it can to get every single one of those workloads back online without the administrator having to do anything. And you can apply that to pretty much anything in the nodes themselves. And it's that type of self-healing and intelligence combined with the efficiency that I think sets us apart.
Okay. That's great. That self-healing and efficiency, that's a great differentiator. So thanks for that explanation. And it looks like we're about up on time. I mean, great presentation. Love the demo, and then thanks so much for bearing with us on this marathon Q&A session. This has been fantastic. But to wrap that up, we'll wrap up with a question from Deb, who's wondering, is there a trial offer we could get? What can people do to get started?
For the record, Deb, I don't know who you are, but you don't work for Scale Computing, and I appreciate the question. Yes, we absolutely do have a demo, and I would welcome everybody as kind of a next step is to, number one, we are fairly transparent about pricing, so go to our website, check out the pricing, and yes, we do offer what we call an HE150 trial, which is that exact node form factor that I was demonstrating earlier. We will get that to you along with our operating system to test out for environments that qualify. And it kind of gives you a very quick glimpse into how things operate, gives you the out-of-box experience, lets you test things like failure mode and that sort of thing to get some real-world testing on the system. It's one thing to say we're easy to use. It's another thing to say, try it out and you tell me how easy we are. And that's really where we lean toward.
All right. Well, great. Okay. Well, Craig, thanks again. Really appreciate you coming on and giving us the update on Scale Computing. This has been fantastic.
I've enjoyed it. Thanks, everybody.
And before we wrap up, we do have one more piece of business. It's the $300 Amazon gift card prize drawing. And the winner of the $300 Amazon gift card is Alicia Clark from New Jersey. Congratulations to Alicia. We'll be in touch to get you your card. And with that, on behalf of the Actual Tech Media team, I want to thank Scale Computing again for making this event possible. And thanks to all of you for attending and for all of your great questions throughout the event today. That concludes our webinar. Have a great rest of your day.